We are ready to go. This is Brad Williamson from SolidWorks doing Thinking Outside the Box.
Take two. Thinking Outside the Box. This is really a presentation that hopefully will inspire you and give you some new ideas to solve everyday modeling challenges without typical sketch extrude type of methods that we'd be prone to use in a lot of situations. And instead, look at how we can use some surfacing techniques, not for making complex organic type shapes, but instead for solving traditional machine design or sheet metal type problems. My name is Brad Williamson, Senior Technical Manager for Dassault Systems. I'm based in Nashville, and I've been happy and fortunate enough to have been helping customers implement, learn, use SolidWorks going back to 1996. So typically when we think of surfacing, a lot of times it connotes industrial design applications, automotive, consumer products, medical, those kind of things. I imagine there's a lot of you here that design more complex organic forms, correct? Okay. But for a lot of what we do, say the internals of all those components, a lot of it's still just traditional machine design, sheet metal, prismatic type parts. So we need some solutions for those kind of things too. So the inspiration for this tech tip presentation really came from surveying customers over the years. And one of the things that we find whenever we talk about surfacing, there's a kind of a stigma associated with that word, right? What are some associations that come to mind when you think of surfacing? Non-parametric. Mm-hmm.
The language is different.
Oh, yeah. Whole bunch of different terminology, especially when you get more into an industrial design. Those folks, are any industrial designers here? They have completely different workflows, different tool sets, different terminology. Words come to mind like organic and swirly and swoopy and complex, sometimes a negative connotation too. Surfacing, it's hard to use, so I stay away from that, or I haven't been trained on that. But there's a lot of different connotations that come with surfacing, and we're not really going to focus on those for this presentation. Instead, what I'd like to do is just present to you a couple of ideas of why you might want to look at some of the surfacing tools, because number one, surfacing sometimes can be a faster, more elegant solution. Hi, welcome. I'm Brad. Nice to see you. And surfacing can sometimes be a faster, more elegant solution than solid modeling. They rebuild faster than solid features, and sometimes they just can get you out of a jam and have less requirements than a solid feature. And really, if you think about it, a surfacing feature is kind of just a 3D version of reference geometry. Planes and curves. These are just sort of 3D representations of those a lot of times. Many times we just use a surface as an intermediate way of solving some other problem. And in fact, there are certain cases where some things you just can't do it without a surfacing solution. So I'm going to propose all of those options to you today. So just kind of in general terms, I'd like to show you in broad strokes a couple of different use cases where surfacing solutions have a really good application. Do you folks use imported geometry a lot? Do you get a lot of step files, Creo files, those kind of things? Sometimes they're complete, sometimes they're good, they stitch up, they're totally usable, but there are going to be cases where you either need to do some cleanup or you need to do some minor modifications. So like in this case, I import the step file and I just need to delete the holes. Okay, so this is perfectly applicable to a sketch and extrude, kind of a hack and fill type of approach, right? We would just go sketch a big block on there and extrude it up. Nothing wrong with that solution. It's just not very elegant. There's a simple surfacing command though that can solve the problem much faster, and it's called delete face. If you've ever used this tool, fantastic way to just pick on an individual set of faces, and it will, behind the scenes, SolidWorks will remove that geometry and it'll stitch everything up and knit it back up into a solid. Really a great solution for cleaning up an imported model. It can also be useful for reparametrizing an imported model. So I've got this imported geometry and I don't like the fillets. I can use delete face to remove those fillets. It restores it back to a sharp cornered version, and now I can do whatever I want with it. I can chamfer it. I can use conic fillets or variable radius fillets. Gives me a new direction to go without having to delete, start over from scratch, and really no sketch extrude traditional workflow like I might have been prone to do.
I'd like to say at this point, that's an example of the terminology that confuses me. I've seen this operation before and used it, but it never feels like I'm deleting a face. And yet sometimes I am, sometimes I'm actually deleting what I've picked and converting it to a surface. So just for your information, I feel like that terminology is tough.
The delete face terminology? Yeah, delete face can be tricky because it can do a couple of different things for you. And we'll see that I'll get into an example that we'll work through in the software, and maybe I can shed some light on that. So delete face can certainly be confusing. Let's look at a couple of use cases here in a minute. Here's another example. So I have this countersink, or this kind of conical type of a revolution going on here, and I'd like to extend that cone out into that rectangular rib that you see there. Once again, perfectly legal to solve this by drawing up a profile and revolving it. But there's a more elegant solution just using some basic surfacing tools that I won't have to do that. And then I don't have to keep track of sketch relations. I don't have to create equations. With a simple sequence of surfacing tools, number one, offset surface to copy that conical face. Number two, extend to make it bigger so that it extends outside the volume of the solid. And the third step is to just use a cut with surface tool. It'll just cleanly remove all that geometry for me. No sketch, no revolve. Nice, clean, elegant solution. That's fully parametric too. So of course, if the underlying geometry changes, that's always going to update. So are these some tools that folks are familiar with for the most part? So and maybe not. So we're kind of hitting the right audience, it sounds like. That's good. Here's another a little more complex use case. So I have this twisted helical type of a spline type feature, and I need to make it longer. Now what's the solution? Traditional solution.
Convert entities on the face.
Yep. Okay, so convert entities on the face gives me the shape, and then I need to know what the helical, the pitch is, the length, and I would just create another sweep on top of the existing sweep. And hope, yeah, probably a guide curve, because that profile is going to get pretty twisty, probably. Doable, and you hope you get it right.
Copy bodies and just put it on the...
Oh, there you go. So that'd be a good idea. If you copied the body and then you just had to rotate it by the right pitch amount. Okay, so that could work.
Takes a playing around.
Yeah, definitely some playing around.
Move face.
Move face might work. That might.
Just looking for suggestions.
That might work. Actually, that might work better, but that's kind of a surfacing tool as well. So direct edit / surfacing tool. So that might work really well. I'll have to try that. Here's the one that came to mind for me. It's a tool called replace face. This is a very powerful command, getting a little off track, but if you do a little bit more with surfacing, replace face is super powerful because it can both remove and add material at the same time. Very cool. In this application, if we just created a planar face, a reference plane, for example, out at the desired length, and then you use replace face, touch on the end face of that spline feature, and the new replacement face, it will then create it'll extend that existing geometry all the way up until the extension face. Yeah, it's super cool because it's 100% exact. Whereas if I had to backtrack what the helical pitch is and copy entities, you know, there's error prone, or there's round off error introduced there. This is going to be exact.
And so would that work if this gear you had was not parametric, that was an imported gear, would it still be able to pull that curve out and work with replace face?
Good question. So the question is, would this work if this is a non-parametric feature? And that's one of the beautiful things about surfacing type features, is that they're They simply rely on the surface geometry, not the parametrics. So this looks at the surface geometry and simply extends it.
But when you pick replace face, could you go back and slide and tell us
Mhm.
which surfaces you're actually picking?
You would pick, in the replace face dialog, there's only two inputs. One is the face to be replaced and the face you're replacing it with. So the face to be replaced is the end feature here, and here's the replacement face. And it doesn't have to be planar. If I wanted that to be some spline surface, it would extend up to that. Really powerful. Asterisk that one as a tool you may want to go back and take a look at. Really powerful command. Love replace face. So those are just a handful of some of the use cases that you can get into. What I'd like to do next with the remainder of our time here is I've got 5 different examples of some common modeling workflows. Not going to model anything swoopy or swirly. We're just going to solve some everyday challenges using some of these basic surfacing techniques. The first example is approaching a filleting problem. Very common. And in this case, I've got a casting, and I apply an edge fillet that you see here in yellow. But of course, in that area where it has to blend, it does some funky things that I'm not real crazy about. I'd instead like something that looks more like that. You could fillet this thing 9 ways to Sunday with all the different ways that SolidWorks has for creating fillets, and you won't get that. There's just not a way to do it. But I'll show you an approach using surfacing tools that is going to make that pretty easy. About 3 to 4 steps is all. Let's give that a shot. So I'm showing you SolidWorks 2019 Beta 3 today, but there's nothing that I'm showing you that's proprietary to that version. All of the commands that you'll see today will go back at least to, gosh, 2010 probably. And not unique to SolidWorks Standard, Professional, or Premium either. All versions. Free tip, by the way, one of my favorite commands, letter R, shortcut for recent files. Just a nice little shortcut that brings up all the stuff that you've been working on lately, so I can have quick access to my last file. So in this casting model, give that a second to open up here. I want a 3mm fillet on this edge. No big deal. Pick on it. From the pop-up toolbar, let's just apply a fillet. And 3mm constant radius. And this is where we run into that challenge because it's trying to blend in with that existing fillet, that it creates this weird little deal here. So I guess the solution I would like to imagine is almost similar to if you've ever done drywall repair. You cut out the bad region and you patch over it with a good region. So we're going to try that type of approach. This is going to require us to, number one, delete the face that we don't want, possibly trim away any extra geometry that we don't want, and then use some basic surfacing tools to smooth over with it. It's about a 3-step approach. First step is the delete face command, which is typically found in the right mouse menus. There it is, delete. I use this all the time, so I customize that on my S key. And John, here's what maybe you were getting at. With delete face, it can sometimes be ambiguous because there's a few different options when you use the delete face tool. The first option to delete will just delete the face and not try to trim it up, not try to seal it up and make it back into a solid. So it deconstructs the model back to a pure surface model. That can be confusing if you don't know that that's what's happening. The second option for delete and patch tries to put an analytic surface over top of it. The third option tries to patch it with what's called a fill surface. Usually one or the other will work better in those cases. If I want it to try to patch something up, I'll use one of these. But in this case, I'm just going to use the straight delete option. And then you'll notice a very subtle thing that's going to happen on screen once I delete that face. You can see through the model now because it's no longer a solid body. It's a surface body with that missing face. if you ever see these light blue edges, those mean that those are open edges. It's not a sealed up watertight solid anymore. The other thing, if you haven't worked with a lot of surfaces, is you'll want to get in the habit of looking over in your feature manager tree, because you will now see that there's both solid bodies and surface bodies.
And surface bodies didn't exist before.
Didn't exist before. Yep, only shows up when they're there.
So if
Yeah.
you use one of the other two delete commands, it would retain the solid body and there would be no surface bodies?
If it were possible to patch it, yes. In this case, what would have happened is it would have deleted that face and patched it up with one that was pretty much similar.
Can you show us?
Yeah, let me come back to that though. Yeah, because it wouldn't have the intelligence to, the problem in this one is it would not have understood that we want this little piece gone here. So it would just patch over this existing and it would look pretty much the same as it was before. Not quite what we wanted. So for our next little piece of this solution, we just want to slice away that little bell curve. Easiest way to do it that I can think of is to just slice a little reference plane through there. So let's create a plane. I like to use the S key to get some of those commonly used commands. So a plane that's parallel to this top face here, passing through this point, is exactly what I want. Now to slice away only that little piece, I'll use a surface trim. Trim surface command, another one of those tools that's really powerful, has a lot of different applications. In our case, we're just going to use that plane as a trimming tool. Now I have to tell it, well, what do I want to trim? I could slice away the whole top of the model if I wasn't careful. So I'm going to be pretty careful about this and say, no, I just want to remove the highlighted portion. And as I hover the mouse over different regions, it shows me what it intends to remove. Real good graphical feedback here. Kind of hard to make a mistake once you know how this tool works. I only want to remove that one little piece. And now once that's gone, I can kind of imagine what this patch should look like now that I have a nice little four-sided boundary. So there's a couple of different ways we could approach this. Anybody have some ideas? Boundary surface, fill surface. Those are the best options. There's a couple that are not as good. Sweep, you could do it with sweep. Wouldn't be as good. Loft, could do it with loft. Not quite as good. You could, yeah, revolve wouldn't work because it would give you only a constant. It'd give you this piece and then you'd have, although you could come in with another patch. Yeah. I think probably the best multi-purpose surface tool in the toolkit is one called Boundary Surface. It works really well anytime you have a four-sided open area that you're trying to patch. It's kind of like a loft that works in two directions.
Can you talk about that a little more? I'm always confused as to whether to use the loft or
A boundary surface, a loft is a subset of a boundary surface. Yeah, loft allows you to specify a start and an end profile, optionally with guide curves, but at its core, it's just two profiles. And you can control the tangency blend on either side of that. So a loft would work here. I would go from this profile to this profile with a loft, and then I'd have to use these as guide curves. The problem with that is I don't get tangency control on the guide curve side, only on the profile side. Whereas a boundary surface, I can control the tangency blending on all four sides. So it's a more robust version of a loft. And it works beautifully whenever you have a four-sided patch. So let's try it. It looks very much like a loft dialog, doesn't it? Direction 1, direction 2, those are where you put your profiles. And it generally doesn't matter. It doesn't give it a preference to what's direction 1 and what's direction 2. I could just as easily go from this profile to this profile as 1, and this one to this one as 2. There's no preference on that. So I'll pick from here to here as my direction 1. And notice these little pop-ups. These are where I can control the tangency, either no tangency at all, tangency, or curvature based. I think I'll just go with tangency matched. So it's going to try to blend that tangency there. This is what I would get pretty much if I were to do a revolve surface here. Right, Monty? Yeah. And that would leave me with this little deal to come back and try to patch over. You could do it. Now in direction 2, I'll pick this edge and this edge. This would be like guide curves if I were doing a loft. But now I have the bonus of being able to say, well, try to give me a tangency match there and there as well. Let's see what happens. Not bad.
It also took, oh no, it didn't take away your surface bodies.
Ah, yes, yes. Good observation. It was, and what tipped you off on that?
That's the first thing I looked for. I just wanted to see if they still retain the surface bodies.
Yeah, so a couple of visual clues here. One is the blue edges. This is not a solid yet. That's one clue. The other clue is over in your feature manager tree. If you expand out here, you'll see that you have now 2 surface bodies, the bulk of the casting and that little patch. So we still have one more step, and that's to knit everything back together and turn it back into a solid. And that's a tool, if you haven't used it before, knit surface, that's going to be our friend right there. With knit surface, we just pick the 2 surface bodies either graphically or from the feature manager tree. And optionally, choose this pick box to create a solid. And if it's possible, it's going to do it. Let's see what happens. Okay, check it out. So visual confirmation here. Solid bodies 2.
I'm curious that it didn't leave the surfaces behind in case some other operation.
They would be there if I roll back.
Sure.
So they were consumed.
Yeah.
Yeah. So 2 solid bodies, just because this is a multi-body part, has the base and then this other piece of casting, but no remaining surface bodies. And that's how I know I've got a nice watertight piece right here. And then just if you are really interested in the curvature here in the blend, I probably wouldn't be. This being a casting, that's probably a non-critical feature. I don't even really care if it's tangent continuous, to be honest with you, but a nice little check on that. If you've ever used this tool on the Evaluate toolbar, it's called Zebra Stripes. This will give you a visual look at what the blending looks like. Almost like if you've ever washed your car on a sunny day and you can see the curvature lines on the body of the car. This shows you where you have little discontinuities. And as we see here, we've got really nice tangent continuity here and here, and even pretty good through here. All right, so not bad. A pretty decent solution to that little problem using the delete face tool, the trim, the boundary surface, and then the knit. Those are pretty standard basic surfacing tools that didn't require us to get too crazy with any solution. I think we have a minute. We could come back and try what happens if I just do a delete and patch on that. We're all friends here, right? So if it craters on me, I don't think it will, but it's not something I've tried before. So let's try this again. Let's put that little constant radius fillet here. And 3 millimeters should be a pretty good size there. So we'll try a delete face once again, but this time I'll try the delete and patch option. Okay, and this one, it fails. It can't patch it. Let's see if it can do a fill. A fill I would expect to work since it is a 4-sided patch. Yeah. It's pretty much the same. Yeah. So that didn't really help us too much. All right, very good. So manual filleting, pretty common challenge, because the fillet tool itself, as powerful as it is, with as many options as it has, sometimes you need that extra little bit of control, especially when working on parts that already have some complex blends or imported parts, manual filleting is sometimes really your only option. Okay, second, before I move on, are there any questions either live or remote regarding that last example? No? Okay, great. Let's move on to another example then. Sheet metal, is that a common use case for you all here? Okay, so let's take a look at a sheet metal challenge. In this case, we have an imported sheet metal part. This one, if you get Creo files a lot of times, Creo does their sheet metal a little different than SolidWorks, and it can sometimes cause problems when trying to flatten. And that's one of those cases here. Even though this was a Creo sheet metal part, I can't flatten it in SolidWorks. I need a flattenable part, and I also want to be able to parametrically modify it to perhaps change the bend radius. So a simple surfacing solution with about 3 or 4 steps is going to give us a developable parametric SolidWorks part. Okay, so I know this is an imported part because right away I get a prompt that says, do you want to try to recognize features on this with the FeatureWorks add-in, which is now in SolidWorks standard. I think as of SolidWorks either 2017 or 2018, this is now all the way down into the standard, not professional anymore. I tried it. I tried using sheet metal feature recognition, and it doesn't recognize the bends. One of the biggest reasons is with PTC sheet metal parts, they don't maintain a perpendicular face to their bends. You can see that right here. And SolidWorks doesn't recognize that as a valid bend. So our approach is going to be to hack away those bend regions and recreate them. Now, what if this part were 0 thickness? It would still look correct, right? It would have the correct form, it'd have the correct bend radius. So one way that we can get this back to a 0 thickness and then create a SolidWorks feature to give it the thickness, one really simple way to do that is to just copy all these faces with a 0 offset. Then delete the rest of the geometry, and then we can recreate our own fillets. So that's the approach I'm going to take. The command that I'm going to use for this one is offset surface. Well, wait a minute, we're not going to offset it. Well, we'll just use a 0 for the offset. That saves us from having a separate command called copy surface. So here I'll pick the faces that I want to offset, and I'll put in a 0 here. Now, it doesn't look like anything happened unless you're really paying attention. You can see the blue edges. That means I've got a surface body on top of a solid body. And also take a look in your feature manager tree. There's surfaces now and there's solids. In our case, we don't need the solid body anymore. So you just delete it. Except, don't just do a delete command on that. That's for deleting features. What we want to delete is the body. And there's a special command for that. Through the right-click menu, easiest way to find it, delete body. And now we only have the surface body representation, so it's a 0 thickness. At this point, we could just apply a thicken command to this, and we should have a valid SolidWorks part. However, that's not going to allow me to parameterize these fillets, or these bends. So I'm going to do one extra step here, and I'll use a delete face command, S key, delete face, and I'll just do a delete without trying to patch that. Enter key is a good shortcut to get the same command that you just issued.
You do those all in the same operation.
Delete face, you can't pick non-contiguous faces, I don't think, unless something's changed, but I haven't tested it. Pretty sure no, that I could not do that in one operation. But with that enter key, it makes it pretty quick. All right, so now the trick is, well, how do I blend between them? 2 steps here. One is to extend the surfaces so they overlap, overshoot each other, and then we'll come back and fillet them. So extend surface, simple surfacing tool, and I'll just pick the edge of one of these parts, one of these little bodies, give it a little tug. And I have to do this in multiple steps as well. So once again, that enter command is really handy. We'll just march around the part like so. So taking a quick look at my feature manager tree, I have 4 surface bodies. And now the goal is to just fillet between them and trim everything up to get back where we were. So trim to do this next step, we're going to use the fillet tool. So fillets are not just for solid features. They work for surface bodies as well. You just want to make sure you use the face-to-face option, the face blend option. I'll pick this face. Right click will effectively move you into the next field of the property manager. So I don't have to move my mouse back here. And then pick here. Now, this is where it's a little bit tricky with surfaces. Because they're 0 thickness, there's potentially 4 solutions to this fillet. So I want to look at my visual preview, and I'll just toggle the directional arrows here until I get the right quadrant. That looks good. And notice how it trimmed everything up for me. Okay, enter key should work for us again. 1, right click, 2, toggle, enter. Enter key again, right click, toggle. Yeah, that looks good.
So if you wanted to take off angle of, that upper right one or the top one, something different.
Mm-hmm.
Would you have to put an eye curve or something? Or a boundary?
I think what I would have done first is back at the point where I have this, I would use a move phase or a move body command, and then I can translate or rotate that one body anywhere I want. That would be one solution. By the way, that question was if I wanted this flange to be at a different angle, then I would just move that body before I trimmed it up. Okay, so what do I have? Still just a surface body, but it's just one body. So now the obvious next step is just to thicken this up, to apply some thickness, whatever my sheet metal wall thickness is. So I'll use the Thicken tool here on the surfacing toolbar. Which direction do I want to go? To the mid plane, to one side or the other? And we'll just put about a 16 gauge 0.06. And now what was a surface body is now consumed into a solid body. But now we have a really nice parametric, at least the bend radii are parametric. I can pick on a value and change it, or pick on a thickness value, change that. I can pick on the fillet radii and change them independently. So it behaves nicely. The only thing we've left to do is turn it into a sheet metal part. Let's get that back to 0.06 where we like it. And that's simply on the sheet metal toolbar. Insert bends, pick the flat face. Since the part already has bends in it, it doesn't even matter what I put in the bend radius. And now I'll notice that it's been converted to a sheet metal part. That should flatten out for us. Yeah, real nice. So we've taken an imported part, cleaned up the geometry discrepancies. I won't say they're errors because there's nothing wrong with the way that PTC makes their sheet metal part. It's just that we can't flatten it. We've turned it into a semi-parametrized SolidWorks part using just a couple of simple commands. So quickly review. You offset the existing faces, delete body to delete the underlying solid, delete face to delete the fillets, extend, fillet, thicken, and insert bends for sheet metal. Okay, so a pretty cool application for a common challenge. Any questions on that one? Yeah.
Way to quickly to compare what you created versus original.
Oh, yeah, a great question. If how would we compare this to the original? One step that I did that if I wanted to retain the original body, I would have just hidden that original body as opposed to deleting it. And then I have two bodies, and I can then subtract them. I can compare them. A couple of different tools that I could use to see what I have. Does that answer the question? Okay.
Is that what delete bodies keep is? So when you go to delete bodies, you have the option of deleting it or keeping it. That's another one of those language things that always confuses me. So is that what you're deleting it, but you're actually keeping it around for future?
I would not have done it. Now this just had one solid body.
Yeah.
So delete bodies deleted the one thing that was there.
Right.
In my case, if I wanted to retain that body for comparison purposes, I just wouldn't have done the delete body command at all. I just would hide it. To your question about when you use the delete body command, there's an option to keep bodies. This is when you have a multi-body situation and you want to delete some and not others. So if I have, like, say 50 bodies, I want to keep 10 of them. That means I have to pick 40? No, I could flip it. So I'm picking the bodies I want to keep versus the ones I want to remove.
So thank you.
Question, Monty?
So I thought when you had it, the offset surfaces and you had it extended and trimmed and
Mhm.
filled in there, I thought at that point you were going to jump straight into sheet metal without the thicken. For some reason.
Oh,
I thought it was going to be that cool. When you were going to
yeah,
jump
yeah.
straight into that.
So can you
So
take
for
a
2020,
can you take a surface body and turn it into sheet metal? As far as I know, there's not a way to do that. It has to be an existing solid. Yeah. That's a great idea for an enhancement, though. All right, let's take another use case. Now this one gets a little bit more advanced. What if you want to create some kind of a non-standard spring? I put it in this basic modeling category simply because springs are common mechanical elements, but they don't always have a circular cross section or a circular shape, a cylindrical shape. Sometimes I need to create these non-standard springs. In our case, what about if we just wanted to create a spring that basically wraps around a rectangular extrusion? Well, let's see if there's a surfacing solution to this one. Just to fast forward a little bit here, I'm going to start with a rectangular extrusion that represents the volume envelope of my spring, basically the center line volume. Okay, so no surprises here. It's just an extrusion with a fillet on it. I want to wrap a helix around this and project it onto the rectangle. So that's really going to be the goal, but we'll use a surface model of a helix in order to do this. So this one may be a little non-intuitive, but I think once you see it, it'll make complete sense, and then you'll extend it to a lot of different other use cases. First thing I want to do is create a helical sweep. But I'm not going to sweep a solid like we think of a lot of times. We take a profile and we sweep it along some kind of path and we make a solid out of it. No, in this case, just think of it like a helical reference plane. That's what we want. So I'll begin by creating two sketches. The first sketch on the front plane, pretty simple stuff. I'll just take a line and constrain it to the origin. So it's exactly the same height coincident relationship, and vertical. Okay, so fully constrained, if my part gets longer, that line is going to get longer with it. That's going to be the sweep path. So I'll exit the sketch. Pro tip, since 2016, if you hit the letter D, dog, it brings up your what are called breadcrumbs, and that just moves the exit sketch command right to your fingertips. Letter D. Okay, so that's this sketch hanging out over here. Sketch 2, that's going to be our path. Now for my profile sketch, once again on the front plane, L for line. I'll just draw a horizontal line sufficiently long enough to go outside the boundaries of my solid. I'm not even going to put a dimension on it. It doesn't matter. As long as, you know, my part doesn't get too big. And exit that sketch. Yeah, you do have to have 2 sketches, even though they're in the same plane. Now let's go to surfaces, the surface toolbar, and we'll just do a swept surface. Swept surface is exactly like the solid sweep. It requires a path and a profile. Here my path is the vertical sketch, and the profile is the horizontal. And that's really uninteresting. It's basically just a planar sweep. However, if you expand out the options down here, there's a little known option that's really powerful. Right under here, nope, second one, profile twist, you can specify a twist value. So it's going to sweep that, it's going to twist that line as it moves up along the path. That was worth the trip, wasn't it? Right, for that one. Twist control, I can do it in degrees, radians, or revolutions. I want 15 turns, so don't make me calculate the math on that. I'll just put in my number of turns. Okay, what happened there? Picked the wrong, got these inverted, didn't I? My profile is this one, and my path is this one. That looks better. Okay, but that's just a surface body. In fact, I'm just going to color that a little bit different so I can keep track. So there's my helical reference plane, so to speak. Now the trick is just to project that helical surface onto the rectangular body so that I could get a curve out of it. Because if I can get that curve, now I can sweep my real profile. Does anybody have a clue on what the tool is we'll use for this?
Surface intercept.
Ooh, close. But really what I want is a curve or a sketch out of this.
Intersection curve?
Intersection curves. This is one of those tools you may not have used before, and it's a little buried in the menus. So you know what? In those situations where you kind of know there's a command for it, you don't use it very often, and you think it might have this name, you go up here to the command search and just start typing. Aha, intersection curve. If you haven't used this before, we put this command search in 2012. Really useful feature for helping you find commands you don't use very often. Number one, I can just pick on the tool right there. And if I never use it again, that's fine. I'll just get it from this menu. You can hit the eyeball and it'll show you where that is in the menus. And if it's not in the menus, you can just drag it from that menu and drop it into your command manager. So it has 3 pretty useful purposes there. So intersection curves lets me pick one or more surface faces or surface bodies. So I'll grab the tangent selection all the way around my rectangular boss, as well as that helical face, and it converts that into a 3D sketch curve. That's cool. And now, just for simplicity, I'm going to pick on these bodies and hide them. Tab to hide, pro tip. Just hit the tab key and those will go away. As of 2018 for multi-bodies, 2013 for components in assembly, I think. But there's my helical sketch, basically. All right, so now we're just going to go straight ahead, exit the sketch, go to my swept boss. And a few releases back, I want to say maybe 2016, since most of the time we sweep circles, we gave an option to where you don't have to go draw the circle. Just pick the path, which is going to grab that whole sketch and load that into the path dialog. And I think I want about a 0.05 diameter on that.
Hey, Brad, quick question.
Mhm.
If I only wanted to do a few segments of that curve,
Mhm.
how would I change the pick?
In this case, it's grabbing the entire sketch. So since you're in 3D sketch mode, just go convert those to construction geometry or delete them or modify them, whatever.
Now that, if you put that on top of your bar, there's
Mhm.
going to be interference.
Correct.
Can you move your guide point?
Yes, I could, but not if I use that option for circular profile. That one always puts it at the center of your
You have
path.
to draw the circular quadrant point on.
Bingo. Yeah. So once again, the question was if I wanted this to sweep on the outside boundary rather than on the center line, then I simply would have manually sketched the profile outside that pierce point. Yeah, good observation though.
You could do an offset surface on those 6 faces.
Oh, that would have been a better solution, huh? Yeah. So offset the outer boundary. I may steal that. Is that okay? Put that in.
I bet it's more work.
I went down to that quadrant where you wanted it.
Is that right? Is that one of the display relations that breaks?
Turn and twist and like wrap
It's possible. Yeah. Yeah, it could change on you. Now, for the most part, this is parametric because remember we started with this sort of a dummy or a sacrificial type of body. So that means I should be able to change the size of the extrusion and the sweep should update, keeping a constant pitch. I didn't modify the pitch. Yeah, and that should update through a reasonable range of parameters. I could probably break it. But now think of all the different applications for a part like this. It doesn't have to be just a rectangular prism. It could be any type of a shape. It could be like a vase. It could be something that if I'm making like a coiled, maybe a toroidal type of a bend where I need to wrap around a torus. No problem, because what is the underlying feature that's making it all happen is that twisted sweep. So it'll twist along any path, any 3D path that you want. Great way to create, coiled tubing, for example. So there's some pretty cool applications you can get out of that that would allow us to create some of those non-standard type springs. Just remember the sacrificial body and the twist along paths swept surface is really the key to that. And of course, we introduced that intersection curves command. Pretty good.
We're talking over here about cables and wire harnesses. Is that kind of how the underlying cabling tool works? Or is that using other tricks?
The routing tool that's in SolidWorks Premium, the question is how do we do cables and wires? The routing tool basically uses sweeps along a 3D sketch. So behind the scenes, you give it a couple connection points and it creates a 3D spline, or in the case of rigid piping, it creates an orthogonal type of path with some built-in rules, like for wire bend radii, pipe bends, and things like that. But it's essentially a 3D sweep.
If you really want to model just a pair of cables, you pick a baseline, go to cylindrical or circular surface sweep, then you do the same helical line with the intersection curve, and you get this weird spatial do the same thing. And then you can sweep it along.
Yeah, it's exactly the same workflow.
Yeah, sounds like.
Yeah, certainly one of those features. If you do decide to do that, to model it, you know, maybe I need it. I need that for an image or a proof of concept or something. I would want to make that a suppressible feature for sure. Because it's gonna bog you down.
With the, you make a feature that has 2 circles and you have a little, make sure it's just 1 image.
So much better.
It's all
Do a little
continuous.
bit of an overlap.
And then you could do a twist on that too.
Oh, so your sketch profile would be like a little clover type shape
Yes.
with these little nodules on a circle.
Yeah, then you could do a sweep like that and then twist.
Twist along the, yeah.
And they don't need to intersect. It can be separate, as long as they run into the connector, and it's in one body.
Can they actually be separate entities?
It's gonna be separate bodies if they don't meet up or something, but.
I looked at doing it, like, overlapping. Maybe it was just because it was the same. That's where I landed. I like that.
Yeah, there's some clever applications for that. Let's see, I think I have 2 more examples to show you. This next example is a little bit more of a straight up machine design type of problem where we have a hole feature with a countersink. Except, you know, if you ever use the hole feature in 3D on a non-planar surface, it always wants that hole to go normal to that surface. So in this case, I would end up with a hole that's kind of on this diagonal, and that's not what I want. I want a hole that's vertical. Yet I want it to be a hole feature for my drawing because it's important that I get the call out correct. To me, it's more important to get to have it be a hole feature so I don't have to manually compose this and run the risk of an error on the drawing, as opposed to the fast solution, of course, would just be to go in and sketch a revolved cut, but then it loses that identity. It's not a hole feature anymore. Now I've got to babysit that call out everywhere on the drawing. So is there a solution that allows me to use a hole feature, but change the orientation? That's the challenge we're going to solve. So here's the incorrect solution. When I place the hole wizard feature on that 3D surface, it comes in normal. Not what I want. And that happens to be as a number 0 flathead machine screw from the hole wizard. I'll just suppress it for now. And I happen to know this center point is 1.25 inches away from center line. So I'm going to put in a reference plane. And this is where the start of the countersink should start at this planar location. So I'm going to drop my hole wizard feature at that location on that plane. Let's see, so it's a countersink for a flathead number 0. Good, it remembered my last settings. Blind direction is fine. And the position I want that to be is just kind of there. Looks like I'll need to go back and flip the direction. And I need to put in a couple of dimensions here. Let's get oriented normal to the sketch plane. Okay, so we want to be on the horizontal with the origin, and then we also want a dimension 1.25. That gives me the correct placement. And I just need to flip that again. There we go. Okay. Need to use a section view though to see what happened. So it created the hole wizard feature on that plane, but it's not smart enough to extend the countersink in the opposite direction. Should be a nice enhancement, but we don't do that currently. So this is going to be one of those cases where I can just copy this conical surface, extend it, and then just use it as a kind of a cutting tool. All right. So let's try that. One little extra step here that may seem non-intuitive, but I have to first copy this surface so that it's a surface body, because right now it's part of the solid. So I'll use the offset surface tool with an offset of 0 and just copy that conical face. And I'm working in section view because that feature is buried inside the model. Okay, so now I have my surface body, but I need to extend it. So I'll hide my solid body. And now we'll just pick on this edge and use extend surface and extend it sufficiently beyond the boundary of the part.
Why would you pick on the edge of the surface?
I only need it to extend in the one direction as opposed to the other. Although that would have worked as well. So you can pick on the face, you can pick on an edge. I just chose to pick on the one edge to extend that. And then when I show my existing solid again, now I can pretty much tell what's going to happen. We really just want to use that as sort of a scoop to remove all that interior. Simple feature here, cut with surface on the surfacing toolbar. The only thing tricky about this cut with surface is 90% of the time I get in a hurry and I cut the wrong direction. Watch this little arrow here. This tells you which direction it's going to remove. So I'm pointing inside that funnel. And this is one where you notice it does not consume the surface. When I use a cut with surface tool, it keeps that surface body, so I can just hide it or delete body. And now in section view, I have the correct solution.
If you delete it, it won't destroy the feature?
Good question. If I delete the surface body, doesn't that delete the feature? In this case, no, because that's a time-dependent feature. When I do a delete body, that becomes a time-dependent feature that happens after it was used. So I'm deleting that body after it's served its utility. And if you're a hardcore surface modeler, anybody here that does a lot of surface modeling, that's a pretty standard technique. If you have a lot of surface bodies that you've created that no longer serve a purpose, you go back and do a cleanup operation by deleting all those bodies that are no longer needed. Does that make sense, John, that it's time dependent?
I believe it.
Okay.
I'd have to see that.
Okay. Well, let me show that to you
When
then.
you deleted the body, it actually added that delete as a feature, right?
It'll be a feature, right? So if I do a delete body, I'm not deleting the feature. I'm adding a delete body feature,
You're deleting the surface body.
but it is a feature.
Yeah.
Delete body is a feature. So it has already served its utility at this point. If I were to roll back, there's the surface body. As I roll forward, now it's deleted.
Yeah, in case we're confused.
Yeah.
Does that have any performance or?
Minimal. Yeah, delete.
It's only one, but you got 1,000.
Yeah, if you have a lot of them, then you probably just want to hide those bodies. But a delete body is going to be a pretty fast rebuild feature.
Would extend face working?
Extend surface is what we used. Yeah, but you have to create a surface body. You can't extend a face of an existing solid because it wouldn't be solid anymore. So you first have to copy that face so that it acts as its own little body. Yeah.
Could you open the surface extend feature? I just want to see the dialogue.
Sure.
So you can go up to a point, up to a surface, or a distance.
Mhm.
It's all.
Yep. All right, then the last step here would just be to mirror. A little bit of a trick here though. What do I want to mirror? Well, it's not really a feature. I could mirror the whole wizard feature, but then I'd have to go through and do that process again. So I could mirror the whole feature and mirror the surface bodies, and no, it's not going to work. Instead, in the mirror dialog, notice that it gives us a couple options here. We can mirror features, we can mirror faces, or we can mirror bodies. So I'll just choose to mirror the faces of this hole about the, I think it's the right reference plane. There. Yeah, and that's going to be quick because it doesn't have to rebuild anything. It just has to copy those faces and do a quick Boolean subtraction.
How does it know that's a full feature?
It doesn't.
The drawing doesn't know anymore?
Drawing doesn't know that. So I do have to put a 2X on there on my drawing, but that's the only thing I have to babysit. I have an accurate hole call out, which is really the reason that I went this direction in the first place, as opposed to just doing a revolved cut.
Is the mirror face, like you change the whole call out, will it change? So if you change the first hole, and just make it a little bigger.
Yeah.
Would it actually mirror that?
Right, because it's making an exact copy of that face geometry on the other side. So it's,
If you had like a slightly different shape, maybe that was a linear flat on the other.
yeah.
It wouldn't, I would say it wouldn't nearly graceful, right?
Well, recall that we, it would try to extend this face. This face is what's called an analytical surface. So it's a true cone, which extends to infinity forever. So it should work as long as we stay within that boundary. But you could break it. I'm sure you could. Yeah. Yeah.
Can it leave you with surfaces whenever it's done? If you got the faces, it lands on something you can't figure out. It will just leave surface of that.
Well, since you're mirroring faces, it's possible that could happen. Yeah. I can't think of a use case where, like in this case, because it's copying faces that are removing geometry. I think if there was nothing there, I think you just get no result. But I haven't tested that. It's a good question. All right, so pretty good practical, more of a machine design type application. Remember that the specific application here is I really want that whole call out. So I wanted to use a whole wizard feature. To me, that was more steps than just doing a revolved cut, but here drafting accuracy was paramount. I'm more of a fan of direct to print and model-based definition, so probably won't use that very much.
Yeah, it's a good time to ask. How many companies are using model-based definition now? It's pretty popular a few years ago.
Yeah, model-based definition. How many are using it? Surprisingly, the defense industry is adopting it pretty quickly. Yeah, there's the new DoD standard requires, or at least gives the option of not including 2D drawings anymore. And in my area where I live in the South, Huntsville, Alabama, for example, we have a lot of defense contracting there, and also like on the Virginia area, we're seeing a lot of adoption there. And the tool's pretty robust these days. The DIM Expert tools that are built in, you don't have to buy the extra MBD license if you just want to do the model-based dimensions. If you want to publish it to a 3D PDF, then you could purchase our MBD product and start trying it out. Yeah.
Anybody using it?
Raytheon uses it.
No, in Alphabet.
Oh, no.
But the more you get into direct to CNC and direct to 3D print, there's just not a lot of call for a drawing anymore. You can put all critical dimensions right on the model. Starting with 2018, we now provide SolidWorks CAM as free. You get free 2.5 axis milling in every license of SolidWorks. And it's tolerance-based machining. So if you put model-based definition or model-based dimensions on your part, the CAM software understands that, hey, this hole has this tolerance. We know how to do that. No need for a drawing. Less and less need for a drawing. So pretty interesting technology. Good question. Okay, one more example for y'all, and we'll take some questions after that. Here's an imported part that doesn't come in as cleanly as we would like, and in some cases has more detail than I would need. Sometimes I get an imported model and I really just need it for space, for an envelope purpose, and I don't need a lot of detail. Well, I can use surfacing features to remove extra detail and to clean up areas where I have some problems. And specifically on this one, you notice this extruded text. Hate it when folks do that to us, but I want to get rid of that extruded text. And number one, it doesn't come in clean anyway. You can see I have open surfaces here. And I don't want this hole. So we'll use a couple of surfacing tools to try to tackle that one. So we come up with this result, nice and clean, and no sketch extrude to try to solve that problem. Here's how we'll do that. here's my imported casting. And a quick look at the feature manager tree. I can see, yep, it's a surface body. It's an open surface. But I have to look pretty closely to see where the problems are. It's right down in here. Look at that.
I'm sorry, I did have one more question.
Sure.
Someone's asking if the medical field is using MPD at all, you know?
Probably. I don't have as much experience with medical customers as much as defense. I would say anyone who is going more CNC and direct to print, then it's a great application for that. And the technology is mature enough to where we really don't have to have drawings. So it wouldn't surprise me if that medical is moving that way. But, direct to print terminology?
3D print. Right?
3D print, yeah.
Yeah, it's funny, you're laughing, you know, those of us who worked 20, 30 years ago, direct to print, just made prints. Prints.
Yeah, means the same thing, just a different printer. Yeah. All right, so we want to clean up this geometry, and I just want to try to avoid a hack and fill type approach as much as possible.
So
Yes.
if that text was like on the inside of the part, is there an easy way to highlight where the problem is?
Then it becomes a little trickier. You can use the tools check command.
Well, in fact, if that's a casting, well.
Yeah, tools check will show you where you have open surfaces, and it would highlight those for you. But if they are inside, it's still probably going to require a little bit of sleuthing, because like it'll zoom in on it, but it can't zoom inside the model. So you'll see, it's like there, but it's inside. So you might have to do some intermediate delete face operations to try to sleuth your way inside that. Yeah, not 100% straightforward. Okay, I think I'll tackle the easy part of this problem first, and that is just to delete and patch over this hole. That one's easy. That's just a delete face command. And this time I'll just use the delete and patch option, because planar surface on one end and semi-planar on the other end. We did a cross section through there. And flip it. Yeah, planar on both sides. Easy. This other one, though, this gets a little trickier. Again, I think of more of kind of a drywall patch approach. If I were just to sketch a little bit of a volume that completely encompasses that text and just delete those faces away, that could be a pretty elegant solution. So I'm going to try sketching on the front plane. And let's see, how about a slot tool? Or a rectangle or anything like that. There we go. And I'm just going to use that sketch then as a surface trim tool. So trim surface using that sketch. And here's one of those cases where you can either keep selections or you can remove selections. I want to keep 90% of it. So I'm going to choose remove selections and then just hover my mouse over different areas and it shows me what to keep versus remove. Here it's pretty simple. Remove all that stuff.
How does it know which direction to remove?
It would go in, it goes in both directions.
So you had selected the other, there's another thing that wasn't highlighted on the other side.
Yes. Yeah, it would have projected that slot. In fact, it would have projected through here, here, and here. It's like, who remembers Real Genius? Remember that movie with the guy who builds the laser in his dorm room and shoots through his room and through the tree and through the lab and all that? Okay, it's kind of like that. It has no relevance to that. I'm sorry. I just wanted to fit in a Val Kilmer reference. Okay. Okay, now we just need to patch over. And any number of solutions here. A fill surface would work. I could revolve over that. I could loft over that. Here's a little hidden gem though, that goes back to, I don't know, SolidWorks. Lars, you probably would know. Let's say SolidWorks 1986. I'm not sure. If you have a continuous boundary on a single face like this, all you have to do is pick one of those edges and hit the delete key. It's a hidden command. There's not even a toolbar command for this. It's called delete hole. Except in 2019, we do add it to the toolbars. But it's been there forever. Just a hidden command, delete hole.
What's the hotkey on that one again?
Delete.
Oh, just delete.
Just delete. Yeah.
That's hotkey.
I think untrim, you talked about untrim, Monty, at lunch. Untrim might work there as well. I think it probably would.
If it's a surface body, it will.
That's way
Somebody asked about untrim. Oh, yeah, it was Lars. Lars that asked about untrim. Yeah, I think untrim would have done the same thing. But the delete hole is just one of those cool little tools that is really good for deleting holes. But it doesn't have to be just circular.
Other options that were boundary surface, or what was the one you're suggesting?
Fill surface would have been, fill is your best go-to when it's not a straightforward four-sided patch.
Okay, fill is kind of a subset of boundary surface, is that right?
Fill is a little more general purpose because it works on any sided. Boundary surface is four-sided patch.
Oh, that's.
Yeah. But when you can, try to get to four-sided patches.
So you can't fill a 5-edged surface with boundary.
No,
You can fill it though?
you can fill it. But it's going to be wonky because surfaces like to have UV parametric curves. They like to have this direction and this direction. So they love four-sided. Five-sided gets a little weird. So if you run into cases where you need to patch a five-sided, can you make it four-sided? Can you do a 4 and a 3? Yeah. Sometimes you have to construct some intermediate curves to play those kind of games. And it also depends on, well, how good of a patch do I really need too? Sometimes if it's just the case of I've got this imported part, I really just need it to be a solid. I don't care that much about what that surface looks like. Then you can use the right tool that gives you the correct level of accuracy. In our case, because it was a single surface, in fact, I think this is a pretty much just kind of a revolve type of surface. Very easy for the software to blend that.
Question.
Yeah.
Could you have done a solid, like extrude cut up to that surface?
No, because a solid cut doesn't cut surface bodies.
You got to repeat the question.
Oh, sorry. Could I? Yeah. Yes. Good point. Could I have just used a solid cut to cut away that text? And the answer is no, because solid features only cut solids. Yeah.
Wait, wasn't that text a solid?
Yeah, wasn't it solid?
No, it was only a surface body. There was no solid body.
Oh.
Yeah. This was just a surface body. That was one of the underlying problems. Is it had holes in it. It was not a watertight solid. So now our last step to take this thing from a surface body to a solid. We think it's closed. We think it's watertight. On quick inspection, I don't see any open edges anywhere. I think it's solid. I think it's watertight. So we'll use a thicken command.
Is there a way to find out if there's an open?
Yeah, tools check. If you use the tools check command to see if there are open edges, sliver edges, and those kind of things. Yeah. There is I'll show that to you here in a minute. It's kind of a weird little Easter egg, but yeah, to turn this into a solid, even though it is a watertight surface, we still need to fill it with solid. So a thicken command works great here. If it's possible to do it, you'll see this option, create solid from enclosed volume. If that's grayed out, that's another tip. Not watertight yet. Still have some work to do. Well, let's do it. See what we get. All right, there we go. Now we have one solid body from that thicken command. And surprise, there's this weird little hammer-shaped extrusion.
But you thickened it, so there's still possibly a cavity inside?
No, the Thicken, great question. When you use the Thicken tool, the two ways that you can use that. One is to give a discrete thickness. If we wanted this to be like a shelled thin wall type part, then we would have entered a value for the thickness. If you don't enter a value and you just say create a solid, it just fills the watertight void with solid material.
Can you
Monty.
repeat the question?
Oh, did I miss that one? Okay. The question had to do with using the thicken command. Wouldn't that have just made the part essentially a thin wall? The answer is no. In the way that we use the thicken command is by choosing this option, create solid from enclosed volume.
Yeah, that's what a shell would be too. It just would happen to have a cavity in it. It's solid though. I guess what I'm saying is.
Yeah, in our case, as soon as I choose this option, notice how it overrides the thickness value.
Okay, that's.
So this is one of those, yeah, certainly the UI designers probably did their best to try to explain that, but this is, it's a dual purpose command. If I want to make that a thin wall type of piece, then I just enter my value here. Yeah. Create solid from enclosed volume, gives us the result we want. This hammer feature that's on the back, that's a mess, and I'm going to leave that for homework if anybody wants to try to clean that up. All right, so we tackled a couple of interesting challenges with this. What do you do when you get these imported bodies that come in that aren't nicely trimmed up into solids and you need to make them solids? Sometimes it's just a matter of deleting some of those bad faces and patching over them, or deleting a feature entirely with that delete and patch command. So that gave us a little bit cleaner result. Not as much detail as we certainly didn't need that level of detail. And we used that little hidden feature called delete hole to remove that or to patch over that little boundary. Really nice. So just to wrap up, I hope you've seen now some different applications to where you can use some of these basic surface modeling tools. We didn't do anything swoopy or swirly, really. Not even the spring. I consider that more of a mechanical part. But hopefully you see there's a little bit more elegance and speed to some of these solutions, because you're really just using a 3D version of reference geometry in a lot of cases. And for some of those problems, I just don't think there was any other option than to use some of these tools. So I hope that maybe you found a couple of tools that you can immediately start putting to use. Or if nothing else, just start thinking a little bit more creatively about some of the common challenges that come to you. And again, thank you for all the questions, both from the room and from our remote viewers. And it's been my privilege to present to you today, and I'd be glad to take some additional questions. Yes, please.
I've used some of the like scan to 3D functionality
Mhm.
for STL, trying to create services from that.
Yeah.
Never worked for me. Is there like some tips and tricks to get that to work?
Okay, so we've used Scan to 3D to create a mesh from a scanned body. What version are you using?
17.
In 17. 17 is not great. 2018 gets significantly better at working with scan data. We now have the ability to take that scan data and turn it into a mesh body right away. So it's going to be more usable. The second thing we do in 2018 is, say you've scanned in what should be a planar surface. Well, the mesh body doesn't see that as a plane. It sees it as a bunch of tessellated features. 2018 has a little painter option that you can now just paint over a series of those faces, and it will interpolate that and turn it into a planar or any kind of analytic geometry, cylindrical, cone, toroid, and so on. So there's some better tools in 18. Try that out, and if you're needing to solve those kind of problems. And I would say too, for folks that are on a prior version and you want to explore some of the new features either in 2018 or 2019, if you'll simply browse to mysolidworks.com, you can register for a free online trial. And this is an in-browser trial. It runs on a remote frame server, so no software to download. but it's a quick way of allowing you to try out some of those new features or features that maybe you don't own, like MDD, for example, is included in that online trial. Might try it and see if the scan to 3D with that same scan file, if that gives you a better result.
Yeah, I have 2018 installed and just pre-deleted 2017.
Mm-hmm. Yeah, 2018 is definitely better, and even 2019, that's an ongoing project, mesh body, so should be getting better with each release. Give it a shot. Hey, John.
Hi, I have kind of an awkward question, but it's a real one. We have lots of colleagues who have their favorite CAD tools, and often the debate comes at surfacing.
Mm-hmm.
Lots of our colleagues will say their favorite tool is much better at surfacing than SolidWorks. What's the reality there, or what's your answer to that?
Okay, so
Can you repeat it?
yeah, the question is when debating surfacing capabilities among different CAD tools, what's my opinion of which one is better?
Well, or you
or
know, so
what's-
how you answer the SolidWorks is better. That's really what your favorite answer. So let's hear that one.
I would say unless you're designing car bodies, I can't think of offhand. I can't think of a surfacing situation that SolidWorks isn't capable of solving. Lars, what do you think?
Because I worked at Makani, who uses NX, and I took a surfacing class in NX. And I saw the big difference is in the curvature continuity controls.
Mhm.
In NX, they have controls that you can zoom right into where that blend is and completely manipulate it. SolidWorks, you have to do it with guide curves or with, you tell it, I want it to be curvature, and it might do it or it might not. In NX, you can physically go in there and start dragging on the thing until it gets to be perfectly curvature continuous, with SolidWorks can't do. But the other, as he was saying, was even at Makani, tangency was fine for aerodynamics. You didn't need to have, the only thing that curvature continuity does for you is it looks really nice. But as far as the wind going over it, it doesn't need to be that smooth. So it's one of those things that people in the air and car are used to, they want a nice smooth body. And so that's why they go with that tools, because they can guarantee C1.
Guarantee C3
Sorry,
actually is
C3.
what they're after. SolidWorks does C1, C2, which is curvature continuity. C3 is the derivative of curvature, and it's primarily auto and aerospace where that comes into play. And if you're talking more, sometimes we're talking about like free-form organic type design, where subdivisional modeling, that push-pull type stuff. We have a partner application called Power Surfacing. It's about a $1,500 add-on that if you need to do that kind of organic modeling, that's a great add-in.
Is that direct modeling or is that?
It's called subdivisional modeling. Yeah, push-pull organic, swoopy, swirly type stuff. Direct modeling would be face manipulation, more prismatic. Like I need, rather than making a parametric extrusion, I just want to grab this face and move it, which we do kind of.
What is that? It's always
Move face command is the primary tool for doing direct editing. Yeah. Yes.
Can you tell us about the cloud offerings that SolidWorks is thinking about?
Yeah, the cloud. When we talk about the cloud, there's a couple of different discussions we have about that. One is storing your data in the cloud, and the other is running the app in the cloud as a browser-based option. So currently we have SolidWorks on the desktop. SolidWorks 2019 is about to release. That's a desktop solution, will always be a desktop solution, and that probably has at least a 20-year runway, because I think there's always going to be a segment of the engineering community who wants to run their software. They want to buy their software and run it on local hardware. So that's probably never going to go away. We're seeing some customers that want the flexibility of running, of having their data in the cloud, and maybe, public storage options are not sufficient for them. So the 3D experience platform is a logical solution. Innovia, for example, like you guys are implementing in some groups, is a cloud-based solution, whether it's an on-premises cloud or a public/private cloud. So we offer that today. Then the next evolution is cloud-based app. We have announced a tool called XDesign that is currently in a beta. If you guys are interested in that, we can get you access as beta testers for that. Think of XDesign. It's not currently offering the full capabilities, obviously, of our mature desktop product, but the idea is that one day that we would have a cloud-based offering as well as a desktop. The vision that our CEO has always had is customers should choose their platform, not have the functionality dictate the platform. Okay, so XDesign runs on the 3D Experience platform, runs completely in a browser, any device, anywhere, for both data and app. Currently is kind of a light version of SolidWorks for modeling and assemblies.
I tried it last year in beta. It was very early.
Yeah. It is evolving quickly. That's kind of the benefit of that tool. Not being version based anymore is that it's always updated. So you don't have to install anything. It's just you turn it on. If there was an update, you've got it.
I guess, are there files with XDesign?
No, it's completely database driven. It's built on the Innovia data structure. It's fully upward compatible to CATIA. Yeah. No, all of that goes away. Yeah. Yeah. A really nice, elegant solution that, we're really just in the beginning stages of getting there. And frankly, customers aren't asking for that yet. The bulk of folks that are running SolidWorks on the desktop are completely happy to do that. And they like the idea generally of owning their software and owning the device that runs on it, that it runs on.
I mean, we would love to be on a web browser, not on.
Yeah, I don't disagree. The problem is there's not a sophisticated enough solution for that yet that the masses are ready to adopt. But yes, Monty.
So aside from this little breakout session, do you have other ones that you actually personally present? Or?
Oh, I'm glad to put together just about any kind of presentation.
Yeah, we'd like to have you come back.
Yeah. Well, thank you. Thank you for having me.
This is one of the best. You're one of the best CAD explainers.
Thank you. Thank you.
Monty and Charlie.
I like to have that in my job title as explainer of complicated things. But yeah, we're glad to, myself and all of my counterparts. This is probably the best thing we get to do in our jobs, is to go out and visit customers and provide some specific type of technical presentation. So
Are you out here a lot?
I can be. This is my first trip. But yeah.
Maybe we ought to put on a
Yeah, give me a couple, 2-3 months.
You know what? Work with Bruce. You tell him what you want, and he will make it happen. And this was a semi-prepared presentation. I tailored it a little bit for you guys, not knowing enough about what you do, but I took some guesses about what you did and tailored it. But we can certainly put together. I have 20 some odd counterparts in North America with a big catalog of ideas to share. So if you can think of it, we can probably put something together for you on short notice.
And we've got a presenter coming in next month from a company called SolidWise. We also try and get Hawkridge in here. So I try and bring in some people besides myself, because you guys have heard all I know.
Well, as
yeah, that's what I do it for, is because.
Well, as Mark Twain says, an expert is a guy from another town.
All right, everybody. Thank you for showing up for our Thinking Outside the Box. We will post this. It's been recorded, so we'll be posting it and sending it out tomorrow. And thanks to Brad Williamson for his great presentation.